Really excited to have David Arnold present measuring racial discrimination in bail decisions. There's a car honking outside my window, so I'm going to mute myself and let David take over. Thanks a lot.
All right, thank you. So yeah, I'd first like to thank the organizers. It's been really interesting to learn about these different perspectives on measuring racial discrimination. And so for my time, I'm going to talk about measuring racial discrimination in the context of pretrial bail detention. And so this is joint work with Will Doby and Peter Hull. Oh, and I should also mention that feel free to interrupt me at any time throughout the presentation if you have a question. The motivation for this project, which does not need too much motivating to this audience, is that we know large racial disparities exist kind of throughout the entire criminal justice system. It's all the way from like the initial stage of police search all the way up to incarceration. We observe large gaps in treatment between individuals of different races. And so there are a number of well-known issues that arise if you interpret these raw disparities or even regression adjusted disparities as discrimination. So one that is discussed quite often is the potential for omitted variable bias. So if you look at raw disparities, there may be some characteristics that are important for determining treatment that vary across race, and therefore the disparities might be driven by those alternative characteristics. If you adjust for those characteristics, there's always the potential that you might leave out some important characteristics that you really should be controlling for in this comparison. Something that I think is also very important, but is potentially not discussed as much, is that there's also the potential for included variable bias. And so that comes in settings in which the goal is to identify disparate impact. So I think the most clear kind of setting for this is you can imagine a hiring setting where there's some characteristic of individuals. For example, maybe they need to have a high school degree that determines whether they get a job or get promoted. And so if this characteristic is not actually related to job performance at all, if this characteristic is additionally correlated with race, then we might get discrimination, even though conditional on having a high school diploma, you find no disparities. So there really is an issue of, what should we control for in order to estimate disparate impact? So then in this paper, we're going to develop some new quasi-experimental tools in order to measure disparate impact, kind of regardless of the source of that disparate impact. We're going to apply these tools to bail decisions in New York City. So before I get into kind of the very specifics of what we mean by disparate impact in this paper, I'm going to give you kind of a broad overview of the bail system in order to kind of guide what we're going to determine is discrimination in this setting. So the bail system in the United States is, following arrest, pretrial release conditions are set at a bail hearing. This usually happens within 24 hours. So at this bail hearing, case and defendant information is presented to the bail judge who has kind of a decision to make. And so one decision is to just release on recognizance. That means releasing without any sort of bail conditions. You're just free to go and you promise to show up at your future court dates. This is the majority of cases in our setting. Around 73% of cases are released on recognizance. Or you can set some bail conditions that's generally a monetary bail amount. If you do not pay that monetary bail amount, you are detained until your trial. And so a non-negligible amount of defendants cannot pay that monetary bail amount, so they are detained before their trial. And so this is a very high stakes setting for defendants, so that if you are detained before your trial, prior work has shown that there's large increases in conviction rates and large increases in non-employment rates that lowers overall earnings for defendants that are detained before trial. Something that we're going to kind of leverage a lot throughout this paper is that the legal objective of bail judges is quite narrow. And so it's to minimize pretrial misconduct. And so we're going to think of pretrial misconduct as either this defendant is going to fail to appear at their future court dates, or they're going to participate in some further crime for their trial. And so we're going to formalize disparate impact as different release rates for white and black defendants with identical misconduct potential. So you should think of misconduct potential as a binary variable here. It's if you're released, are you going to participate in pretrial misconduct or not? So one last thing to note is that there are large and persistent white-black release rate gaps in most systems. So in most systems, white defendants are more likely to be released than black defendants. So in New York City, which is going to be the setting of this paper, If you don't control for anything, there's about a 7 percentage point gap overall, and it only decreases to around 5 percentage points after you control for things like the type of charge or prior criminal history. So the first question we're going to ask in this paper is how much of this gap is due to differences in misconduct potential and how much is due to discrimination. So before I get to what is our measure of discrimination, what is it going to capture, how do we estimate it, I want to talk about kind of the two legal doctrines in the United States of what constitutes discrimination and where we think of our measure as coming from. And so, as I've mentioned, ours is really going to be coming from disparate impact. So there are two doctrines though. One is disparate impact and one is disparate treatment. We're going to focus on disparate impact, but it's important to note that these two notions require different statistical evidence. So the statistical evidence we're going to find is going to be most closely related to disparate impact. And so disparate impact is concerned with discriminatory effects of a policy or practice rather than the decision maker's intent. And so one thing to highlight is that a race-neutral decision practice can still be discriminatory if there is no legitimate justification or if there is a less discriminatory alternative. So the original kind of disparate impact case was in the employment setting. It was Griggs versus Duke Power Company, and it involved Duke Power Company having high school diploma requirements for promotion. The type of job was a manual labor job. And the courts found that you really didn't need a high school diploma to do this job in a successful way. And the fact that the Black workers were much less likely to have a high school diploma implies that this had a disparate impact on Black workers. And so a key question in alternative settings, we're not looking at employment context, is how to define what is a legitimate practice. So in employment context, the US Supreme Court has related legitimate to things like bare relationship to job performance. In lending, banking regulators has explained things like cost, profitability, and other objective measures are legitimate justifications. In our setting, we're going to formalize this as pretrial misconduct. So if your decisions are related to the latent pretrial misconduct potential of the individual, then that is a legitimate justification for the decisions. All right, to really pin down exactly what we're after, I'm going to introduce a little bit of notation now. So we're going to have defendant is going to be indexed by I, judges are going to be indexed by J. We're going to let YI star be the unobserved misconduct potential of a defendant. So if YI star equals 1, that indicates that if this individual is released before their trial, they will engage in pretrial misconduct. YI star is equal to 0. If they're released, they won't. It's unobserved because some defendants are detained and we will never see whether they would have behaved in pretrial misconduct had they been released. DIJ is going to be the decision of the judge. So if DIJ equals 1, that indicates the individual is going to be released. If DIJ is equal to 0, that indicates the individual will be detained. Again, if DIJ is equal to 0, we never observe the misconduct potential because an individual who's detained can't participate in further crime or fail to appear at their court dates. RI is going to be race. So we're going to say that a judge discriminates if she releases white and Black defendants with identical misconduct potential at different rates. So delta J is going to be our main measure of discrimination in this paper. The inner difference here is really just saying, what is the difference in release rates for defendants with the exact same YI star, so the exact same latent misconduct potential? The outer expectation is just averaging over the distribution of misconduct risk. So what proportion of people in the entire population are going to behave in pretrial misconduct versus not? So what I've alluded to earlier was that the key challenge here is that YI star is not observed for some defendants because they're detained before trial. And so it's not possible to just look in the data and construct delta J. So this is actually a very pervasive issue in many settings where we'd like to measure either decision maker discrimination or algorithmic discrimination. So for example, in the employment context, you'll never know the job productivity of an individual who's not hired. In the banking context, you'll never know the default rates for individuals that are not given loans. So this is kind of a pervasive issue. And really our main contribution is to show how you can use quasi-random judge assignment, or more generally, quasi-random assignment of decision makers in order to overcome this measurement challenge. So we're going to really leverage the fact that in this setting, the case a judge is assigned to is effectively random. So you can imagine other settings like banking. If you have loan screeners that are randomly assigned to different loan applicants, you could also leverage something similar to the approach we leverage here. Another way to talk about the generalizability of this is we've chosen one delta J that we think has some nice properties. It's related to previous research and theories in the economics literature, and it's related to the legal doctrine of disparate impact, but you might have some different measure of fairness that you would like to measure. So in computer science, a lot of these measures are going to depend on type 1 and type 2 error rates. And so estimating those type 1 and type 2 error rates is actually the exact same selection problem here, is that you need to identify outcomes for defendants that are censored. And so if you have a different notion of fairness, but it depends on true qualification rates, this procedure that I'm going to go through can be adapted in order to estimate that. And so in kind of follow-up work from this, instead of looking at DIJ here, which is judge decisions, we've started looking at algorithmic predictions or algorithmic decisions in here, and kind of all the same steps follow through if you're instead looking at algorithms. So I want to go through again what our measure of discrimination captures relative to kind of prior literature on discrimination. So first, again, a positive delta J is going to imply white defendants are released before trial at a higher rate than black defendants with the exact same misconduct potential. So what modes of channels will drive this is it could be discrimination, this actually is very similar to a discrimination that's discussed in Aigner and Kane, who compare labor market treatment of workers with the same level of productivity. And so these differences in release rates between defendants of the same misconduct potential can arise from racial bias, as in a kind of a classical Becker sense. It could arise from stereotypes, so that's inaccurate beliefs, which we're actually gonna kind of bucket into this racial bias bucket, but could also be thought of as inaccurate statistical discrimination. We're not going to be able in this paper to distinguish those two things. But either racially biased preferences as animus or stereotypes will lead to different release rates for defendants with the identical misconduct potential. Also, accurate statistical discrimination, as classically discussed by Arrow, Phelps, and Aigner and Kane, will also lead to differences conditional on true misconduct potential. So it's kind of an omnibus measure that captures many different types of discrimination. And so we think it's important because all these different types are potentially illegal. And it will also capture unwarranted disparities from seemingly race-neutral policies. So as I discussed before in the employment context, if the decision is conditioning on something that's not actually related to job performance, so in this case, it's conditioning on something that's not actually related to pretrial misconduct potential, even though once you condition on that observable, there's no disparity, it will also capture discrimination that arises from those race-neutral practices that have disparate impacts. So we do have a second contribution in the paper that I don't think I will be able to talk too much about, but I just wanted to flag is that, our measure captures a lot. And so in order to kind of come up with a policy response, in some cases, you might want to know exactly what's driving this unwarranted disparity. And so we do at the end have a model that allows us to kind of disentangle, is this racial bias, is this statistical discrimination? But I don't think I'll have much time to discuss that. Okay, so before getting into the details, I'm just going to go over the kind of what the key challenge is again and how we're going to actually go about solving it. So the key challenge is that misconduct potential is unobserved for detained defendants, so it cannot be conditioned on directly in order to measure disparate impact or discrimination delta J. The key insight is that with quasi-random assignment, you only need to estimate average misconduct rates. You don't actually need to observe individual misconduct potential. So it's similar to kind of a selection correction type intuition where you don't need the individual level qualification rates, you just need to selection correct the relevant moments. If you want to think about this in kind of a classical omitted variable bias framework, the omitted variable bias in those observational disparities is going to arise because there's some correlation between race and unobserved misconduct potential, which is really what we'd like to condition on here. Under quasi-random assignment, this correlation is going to be common to all judges, and therefore it is further just going to be a function of average black and white misconduct risk. If there is not random assignment, then the types of cases, the correlation may not be common, and we wouldn't be able to solve this problem by just estimating 2 moments in the data. So what we're going to do is we're going to first show how this result, and then we're going to discuss how to actually estimate average black and white misconduct risk. The way we're going to do that is we're going to extrapolate local instrumental variation. But intuitively, what you should think we're doing is that, imagine a case where you just had a very lenient judge that releases all defendants regardless of, any characteristic of the defendant. In that case, you can just look at the misconduct rates of the defendants assigned to the supremely lenient judge. And because of quasi-random assignment, these misconduct rates are going to be equal to the population average misconduct rates. It's as if you had an experiment where you just randomly selected defendants and released them and looked at their misconduct rates. So we're not going to have a supremely lenient judge, but instead we're going to build on recent advances in estimating average treatment effects to extrapolate to such a hypothetical judge that will allow us to estimate the average misconduct rates by race. All right, so this is building on a long literature on testing and estimating discrimination. So a lot of the theoretical channels that have been discussed are going to be contributing to this measure of disparate impact that we're measuring. And it's also building on kind of experimental ways to measure discrimination, such as an audit study. Though it is going to be estimating a slightly different parameter than an audit study, because decisions that depend on characteristics that are correlated with race will still impact our disparate impact, but will not be identified by an audit study. In order to kind of measure our discrimination, we're going to need estimates of average misconduct in the population. You can think of those as average treatment effects. So we're going to leverage some insights from how to estimate average treatment effects in order to estimate our average misconduct inputs. All right. So getting to the setting of the data, we're going to observe all arraignments in New York City from 2008 to 2013. The key variables are going to be race, where we're going to categorize defendants as either white, which was going to include both non-Hispanic and Hispanic whites, or black, which includes both non-Hispanic and Hispanic blacks. So we're going to compare differences in release rates between these two groups. Our main treatment here is going to be pretrial release. And so that's going to be an indicator for any release type. When I say any release type, that means either release without any conditions, or you were set some monetary bail and you paid that monetary bail and were released. So in our setting, around 73% of defendants are going to be released before their trial. Main outcome or qualification is going to be pretrial misconduct, which is going to be an indicator for either failing to appear or being rearrested prior to your disposition. So conditional on release, around 30% of defendants do participate in pretrial misconduct. We're also going to have access to some case and defendant characteristics such as crime, age, criminal history. So again,
David,
yes.
If there's discrimination and arrest, potentially be some sort of built-in bias in what's categorized as pretrial misconduct.
Definitely. So yeah, that's a good point. So we have to hold fixed all those potential biases on either side of entering into pretrial detention or being rearrested for pretrial misconduct. So the way that, so yeah, just as you said, if police officers are more likely to rearrest a black defendant relative to a white defendant, then we'll overinflate the differences in misconduct rates between white and black defendants, which means in practice, our estimate of discrimination will be too low. The one thing we do to try to address this issue is that we do focus on failure to appear in some case, in kind of a robustness check. And so the reason why that might be less susceptible to this is that it's kind of just written down whether you failed to appear in your court date. It's not really something that is up to the preferences of police officers. And so if we just look at failure to appear as a pretrial misconduct, then we find very similar results overall. So in total, we're going to have around 500,000 cases, around 300,000 defendants, and a little bit over 250 judges. So just to show you some descriptive stats, in panel A, we have pretrial release. So again, overall, 73% are released. White defendants are released at a higher rate, around 77 percentage points, than black defendants, around 69.5%. Conditional on release, the type of release is quite similar. So share ROR means 85% in both groups were released without any bail conditions. So they didn't have to pay any money to be released. Around 14% had to pay some monetary bail in order to be released. And these are quite similar actually across the two groups. Turning to defendant characteristics, black defendants have slightly higher prior rearrest and prior FDA. Charge characteristics are actually relatively similar between white and black defendants in this sample. Looking to panel D, which is our main, this is what we're going to want to selection correct for, differences in pretrial misconduct rates. You can see that white defendants have slightly lower pretrial misconduct rates than black defendants. But again, we can't really determine the overall misconduct rates here. And the reason is because we don't know the misconduct rates of individuals that were detained, and we know black defendants were detained at higher rates than white defendants. And so the goal here is, first goal of the paper is going to estimate average misconduct rates, not misconduct rates conditional on having been released. Okay, to provide some motivation, we know that the kind of overall mean is much higher for overall release rate for white defendants is much higher than black defendants. It's also kind of interesting to know what the distribution across judges is. And so in this figure, we're plotting the distribution of the posterior release rate disparity. So a positive value here indicates that the judge is more likely to release a white defendant than a black defendant. So the blue here, which is shifted to the right, is what we're calling strata adjusted. So that means we're just adjusting for the level of random assignment. So those are court by time fixed effects. And so within court by time fixed effects, the judge you get is effectively random. So you can see the mean across all judges is around 6.6 percentage points, but there is kind of significant variation across judges. But somewhat importantly, almost no judge has a negative posterior release rate disparity, meaning almost all judges are more likely to release white defendants than black defendants. If you adjust for covariates, the distribution moves to left, so there's a lower disparity between white and black defendants. The mean is still around 5 percentage points, and it's still positive for almost every judge in the sample. So these covariates are things like, do you have prior arrests? What's the charge you're being charged with? What's your age? So this is evidence of potentially substantial disparities, and they're kind of pervasive across every judge in the system. Okay, so now we're going to go to the main goal of the paper, which is how to estimate differences in release rates that actually condition on latent misconduct potential. And so what this is, delta J is the goal of the paper to estimate this parameter. What we observe in the data is RI, which is the race of the individual. We observe judge assignment, ZIJ. So ZIJ is equal to 1 if defendant I is assigned to judge J. We observe the release decision of the defendant, which is the release decision of the judge that the defendant is actually assigned to. So this is observable. And we observe pretrial misconduct if released. So we observe YI, which is equal to the interaction between release and true latent misconduct potential. And so the way you read this is that if DI is equal to 1, that means the defendant was released, and we will observe whether this defendant behaves in pretrial misconduct or not. If DI is equal to 0, it's always 0, and we never observe that individual's YI star. So that's why we can't directly compute this. What does random assignment give us? It gives us, differences in release rates of judges, alpha J, but it doesn't give us differences in release rates conditional on misconduct. So generally, when there's differences in misconduct rates across race, this alpha J is not going to be equal to delta J, which is our parameter of interest. To go through the solution, we're going to do a very simple numerical example where we have a race neutral judge and discuss how we can selection correct the data in order to get a kind of the right level of disparate impact. So we're going to consider two races. One, we're going to have be the H type, which are high risk individuals, and another is L, which are low risk. So we call them high risk and low risk because overall the population of H is more likely to behave in pretrial misconduct than the population L. So mu H is the average misconduct rate for H types. We're going to suppose there's a race neutral judge that releases 80% of defendants with YI star equals 0 and 20% of defendants with YI star equals 1. So this is a judge that's relatively good at predicting who's going to behave in pretrial misconduct. They release most individuals that are not going to behave in pretrial misconduct, and they detained most individuals that will behave in pretrial misconduct. But there are some errors, so it's not a perfect judge. So we can think about, what do kind of raw release disparities look like in this population, even though we've set it up so that the judge is completely race neutral, and we know the disparate impact here will be 0 because conditional on YI star, it's always 80%. So it's 80% for for H defendants and 80% for L defendants. But if we look at the average release rates, since we've set this up, we can, in column 1, compute the number of defendants of each type for both L and H defendants. We've set it up so H defendants have, L defendants, 75% of them will not behave in pretrial misconduct, while 25% will. So overall, the number released given this decision rule is 65, and so we get a release rate of 65%. For H defendants, their kind of misconduct potential is flipped. So 75% of H types will behave in pretrial misconduct, 25 will not. That leads to an overall release rate of 35. So therefore, our overall release disparity is 30 percentage points. So of course, this is not, we know disparate impact in this case will be 0 because conditional on true Y star, there is actually no release rate disparity. So this is going to skip a lot of steps, but what we show in the paper is that under quasi-random assignment, delta J is identified by a rescaled regression. So we're going to construct weights that allows us to make the two types of defendants comparable in terms of average misconduct. These weights are going to be called omega I, and they're going to be given by this equation here. And so this equation might not be the most intuitive at first, so we're going to go through the example of what this is actually doing. But the key point is that it depends on only two parameters that we don't know or can't observe, but there are two parameters that we can potentially estimate. So those two parameters are the average misconduct rates for each type of defendant. So that's mu RI here. Once we estimate that, we can estimate mu bar, which is average misconduct in the entire population. This is YI, not YI star, so this is observed. So again, intuitively what's going on is that we're going to be rebalancing the sample to make white-black release defendants comparable on average in terms of their misconduct potential. And so given we've set up this problem, we can just construct our rescaling factor for each type of defendant. So again, we have of L types, those who do not behave in misconduct, we have 60 of them are being released. If we construct their rescaling factor, they're going to be downweighted. And the reason why L types are downweighted that do not behave in pretrial misconduct is because they're relatively more common. So L types are more likely to not behave in pretrial misconduct, and therefore the individuals of L types who do not behave in pretrial misconduct are downweighted. L types who do behave in pretrial misconduct are relatively less common, so they get upweighted by a factor of 2. So then you can get the rescaled number of release by just multiplying column 1 by column 2. So then you get 40 and 10, which is an overall release number of released of 50. And so we get a rescaled release rate of 50% of defendants being released, given this rescaling factor. For H types, they're relatively more likely to behave in pretrial misconduct, which is why y star equals 1 gets downweighted, y star equals 0 gets upweighted, leads to an overall release rate of 50% again. And once we've rescaled based on our estimate of omega, we get a rescaled disparity of 0%. So that we can interpret these rescaled estimates as racial discrimination under the assumption that bail judges are as good as randomly assigned. The legal objective of judges pretrial misconduct is both known and well measured among released defendants. You can also choose other objective notions and use those as the metric as well if you want to show robustness to this second. Third, what I'm going to talk about now is we need to be able to consistently estimate 2 race-specific misconduct rates, which I haven't really gotten into the details of how we do that, given that is also a key hurdle is the censoring of individuals who are detained before they're released. So the nice thing about this is that you don't need any model of judge behavior or about what information set the judge gets. It's kind of a model-free estimate of disparate impact. So yeah, I don't think I'll get to it in this, but you can impose more structure if you do want to kind of disentangle where this is coming from. Is it racial bias or is it statistical discrimination? Okay, so now just to recap, the kind of problem of having to condition on latent misconduct potential is now reduced to estimating just 2 moments in the data, which are the average misconduct rates for white and black defendants. So we're going to imagine a judge that releases everyone, and by random assignment, the misconduct rates for this judge are just going to be equal to the overall average misconduct rates. And so absent that judge, we're just going to extrapolate using variation from judges that have high release rates in order to estimate what would a judge that hypothetically releases all defendants have for their misconduct rates. It's similar to kind of extrapolating mean potential outcomes to an RG cutoff, with an important distinction is that you don't have data on both sides of the cutoff. You can't have over 100% release rates. Then formally, it's going to be identification at infinity, basically, where if you have a judge that pushes you all the way to a release rate of 1, then you're non-parametrically identified. If you don't, you need to form some parametric restrictions in order to estimate these misconduct rates. So to give you a picture of how this works in practice, on the x-axis here, I have the release rate of the judge. The y-axis, I have the pretrial misconduct rate of the judge when those of the released defendants to the judge. So every x here is a different judge. So if you have here a supremely lenient judge that releases all defendants, then it's kind of non-parametrically identified. You can just look at the y-axis and say, okay, the defendants for this judge had a misconduct rate of around 42%. That's the overall misconduct rate in the population, because the defendants assigned to this judge are just a random sample of all defendants. So generally, you're not going to have a judge that is so lenient. So what you can do is you can use variation from judges that have lower release rates. So here we're just going to fit a line, and we're asking, where does this line hit the x-axis at 1? And so that will be that's the release rate of an infinitely lenient judge. And we can look on the y-axis again to say, theoretically, what is the pretrial misconduct rate of this judge? You can kind of see, if you only have a few judges, it's got to be a pretty parsimonious extrapolation. If the more judges you have, kind of the more nonlinearity you have, the closer those judges are to a release rate of 1, the more closely you're going to hit those average misconduct rates. And so what we're going to do in practice is we're going to do this separately by race. And so that will allow us to estimate race-specific misconduct rates. All right, so this is a big switch to the actual data now, where we're plotting the release rate for every judge and the pretrial misconduct rate when released for every judge by race. So every circle here is going to be the estimate for the white defendants assigned to that judge, and every orange cross is going to be the estimates for the black defendants assigned to that judge. And so what we're doing here is we're fitting different curves to this data. So we have a linear fit, a quadratic fit, and a local linear fit. And our question is where do these curves intercept the x-axis at 1? And that will give us the average misconduct rate for that defendant population. So you can see is that these curves, this point is really what we're interested in for each race. And these curves are relatively similar no matter how you kind of do the extrapolation. And so we'll just show kind of what are the different estimates of discrimination depending on which exact extrapolation you choose. Okay, so then this is these estimates of the intercepts in that prior figure. So if you use a linear extrapolation for white defendants, it hits the y-intercept around 0.338. This is the average misconduct rate for the white defendants in this population is around 33.8%. For black defendants, we get an overall misconduct rate of around 40%. So this is going to indicate that kind of the raw disparities, a portion of that might be due to differences in misconduct potential across races. But the question is how much, and that's where we're going to go to our our reweighting and rescaling approach to understand if you put these estimates of average misconduct in, what does that mean for systematic differences in release rates conditional on true misconduct potential? You can see they're relatively similar across different extrapolation methods, and the gaps between them are relatively similar across different extrapolation methods. So this is just to remind you that we need to actually use these inputs in order to estimate discrimination, because we use them to estimate these weights, which allows us to estimate overall discrimination. And so this is the kind of key results in the paper, is that we estimate system-wide discrimination. We can look at the most conservative estimate of 0.042, which it comes from the local linear extrapolation. This is saying that conditional on true misconduct potential, white defendants are 4.2 percentage points more likely to be released than black defendants. And so we can show you how this varies across judges as well. And so what we're doing is we're calling unwarranted disparities our measure of discrimination. Again, these are disparities that condition on the true qualification rates of the defendants. So you can see when you correct for the true qualification rates, the distribution does move to the left. That means the disparities are lower once you correct for Y star or qualification. On average, though, it's still 4.2 percentage points across all judges, so that's a significant level of discrimination. And if we look at the dispersion, there is actually quite significant dispersion. So judges are differentially discriminating. But again, almost all of the judges are to the right of 0. So this is a setting where almost all judges' decisions have some disparate impact on black defendants relative to white defendants. So we can look at what may predict this variation across judges. And so we do not have that many judge characteristics. We only have characteristics that can be kind of constructed from the sample. For example, does the judge come in to our sample during the period? Is the judge lenient? Are they assigned different levels of black versus white defendants overall? And so newer judges are slightly less discriminatory. Lenient judges are slightly less discriminatory. Defendants that are assigned above median black share are slightly less discriminatory. There's some very important variation across courtrooms in this setting. So the Manhattan courtroom relative to the omitted courtroom, which is Kings County here, has a 3.6 percentage point higher levels of discrimination than Kings County. And so this is quite significant difference across the different counties. I'm going to omit the split samples, but we also show that this is something that's persistent over time, that if you estimate the judge's discrimination in the first half of their data, try to predict what it is going to be in the second half, that's going to be a relatively good prediction. There are many potential concerns of this method. So we're going to go through kind of the robustness checks quickly. So you might think, maybe we didn't do the right way to extrapolate, and you're worried about that extrapolation doing a lot of work. So we do show different extrapolation methods in the paper. We also do non-parametric bounds on mean risk without extrapolation. So that's saying, let's just use, the most lenient judge, and then kind of assume kind of the worst case scenario for the rest of the defendants that we don't actually observe. And so that will give you bounds on how large discrimination could potentially be by just using variation that we actually observe. And then still, there's kind of a non-negligible and positive level of discrimination, even with those kind of non-parametric bounds. Another thing is that we are extrapolating across location in some of these. So we're kind of using a judge in Manhattan as a comparison to a judge in Kings County in order to extrapolate to a judge with a release rate of 1. So what we do in the paper is also do this completely separately by the different boroughs, and then aggregate across boroughs by averaging by the case share of each borough, and we get similar results. You might be concerned about the definition of misconduct. So again, things like rearrest might be potentially biased if police officers are also biased in who they rearrest. So we show, it's pretty consistent whether you look at just failures to appear, just rearrests. Violent rearrest gets quite noisy because it's a relatively rare outcome. But again, it's the level is similar, but it's just much less precise. Another potential concern is the different judge decision variables. And so we're taking it as release versus detain. You could also think of it as release without any conditions versus release with or any bail conditions. And so we do that alternate decision of the judges. We find relatively similar results for that different categorization, as well as different categorizations of race. All right, this will be a very, very quick last part on kind of the model-based, which is going to use a lot more structure as a way to understand kind of what are the sources and, think about some simple policy experiments to understand what could be effective at reducing discrimination. Okay, so we're going to assume that judges see signals of individuals' misconduct potential, Y star. They form some belief given that signal that could also depend on race. So this is going to be as in statistical discrimination models. We're going to allow beliefs to be inaccurate. So judges are going to release defendants if the posterior risk is beneath some threshold for release. And so racial bias here is going to be inaccurate beliefs or racial animus are going to imply that the effective thresholds are different by race. We're not going to be able to do anything to disentangle those two sources. What it's going to do is it's going to yield discrimination kind of at the margin, where if you look at the last defendant that is released by judges, their misconduct rates are going to be different, and that's what's going to be kind of capturing racial bias in our setting. But that differences in misconduct at the margin can be driven by inaccurate beliefs or kind of classical Becker taste-based animus. It could be also driven by accurate posterior beliefs that actually depend on race in an accurate way. So that's going to be true whenever mean risk and signal quality varies across race. So in order to kind of bring this model to data, we do need to impose a number of assumptions on what these different thresholds and what these signal quality across judges looks like. So we're going to assume distributions for each of these parameters. Sigma JR is going to be the signal quality of different judges. That's going to differ by judge skill. It's going to violate conventional first stage monotonicity, but I'm not going to focus on that now because I do want to leave some time for questions. But what this structure is going to give us is relatively strong, but it yields a model in which we can disentangle bias from statistical discrimination and quantify those in terms of how much they generate differences in release rates. So the nice thing about this model that I probably won't go through too much is that the parameters are pinned down by kind of relatively transparent moments in the data. And so we're going to estimate the model parameters by simulated minimum distance. And so what we need to estimate again is mean misconduct risk is exactly the same as before. High risk individuals, if we look across release rates, if we look at the intercept at 1, that's just going to directly identify the mean misconduct rate for different types of defendants. Signal quality is going to be given by these slopes. So if you imagine just a single judge is making these decisions and you're forcing that judge to release more and more defendants. A judge that is very good at making these decisions will initially release almost no one. Then as soon as you force their rate of release to a high enough level, they'll start releasing relatively risky defendants. So you'll see this very stark relationship. A judge that has no signal quality basically will randomly release defendants. And so you'll see something that's flat because for every release rate, you kind of get a random sample of defendants. Signal quality variance is going to be given by dispersion in the y-axis. So you can think of this as if I have two judges, they both release 70% of defendants, but one is releasing defendants that are misbehaving at very high rates, one is releasing defendants that are misbehaving at very low rates, then that judge that's only releasing the low misconduct must have very high ability to detect who is going to be misbehaving. The one that's releasing at high rates clearly does not have a high ability. So if there's a lot of variation in the y-axis, that's going to mean signal quality varies quite substantially across judges. And so when we estimate the model by simulated minimum distance, we do find evidence of both racial bias and statistical discrimination. So bias is kind of a higher effective threshold for white defendants. Still, statistical discrimination actually has two components. One is the mean varying and one is the variance varying. So statistical discrimination exacerbates discrimination because the mean risk for Black defendants is estimated to be higher than the mean risk for white defendants. Therefore, when a judge sees a Black defendant, that goes into their posterior belief and increases the probability conditional on the same signal for a white and Black defendant. Lower signal quality is actually going to alleviate discrimination for Black defendants. So judges are not as good at predicting misconduct levels for Black defendants. That brings it closer to the posterior mean, which is in this particular setting is going to actually alleviate discrimination because most defendants are actually released before trial. But that's a very particular result to this, this setting. We do some counterfactual simulations to really try to understand whether these are reliable. And so if you actually target the discriminatory judges that are estimated to be discriminatory by our method, would you actually be able to reduce, or is there just too much noise in this process to reliably estimate who's a discriminator? And we find that you can virtually eliminate all discrimination if you use the posterior estimates of discrimination, but just targeting the observational disparities without kind of the fancy correction also reduces discrimination significantly. So I'm going to skip these policy simulations in the due to time, but just to conclude, what we do in this paper is we develop new quasi-experimental tools to measure discrimination. A key part of this approach is to estimate average misconduct risk by race, and then use these average misconduct rates to appropriately rescale observational disparities in order to kind of purge omitted variable bias and make white and Black defendants comparable in terms of misconduct potential. What I didn't get to talk too much about is this Numerical MD model that allows us to explore kind of what's driving it. And so what do we find? We find significant racial discrimination in NYC bail decisions. Kind of 2/3 of what our observed release rate disparity can be explained by discrimination. The model shows that both racial bias and statistical discrimination are kind of important in this setting. And so we think the methods might be very useful in other settings. So in particular, if you're not interested in judge decisions, but instead interested in algorithm decisions, you can use these tools in order to estimate algorithmic discrimination. If you're interested in different notions of fairness that have been developed in the computer science literature, you can still use these tools to overcome the selection problems that are common in many of those different notions of fairness. If you're just interested in different settings, there are many different settings that have quasi-random assignment of decision makers, such as lending, hiring. And so you could potentially apply these tools in those settings as well. All right. So yeah, in the ongoing work, we are developing new methods that I've alluded to in order to measure and correct racial discrimination algorithmic predictions. So machine learning predictions of pretrial misconduct, resume smell testing recommendations have the exact same omitted variable bias selective label challenge because you don't see individuals' outcomes if they're not hired. You don't see their outcomes if they're not given the loan. So in ongoing work, we're going to show how to kind of measure these algorithmic discrimination requires estimating more moments, but once you estimate those, you can again estimate algorithmic discrimination. All right, so thank you for your time. I'm happy to take questions now in the few minutes remaining.
Cool. Thanks a lot, David. That was great. Really interesting work. Yes, I just want to open it up for questions. As before, just raise your hand or just you can just start talking as well. So we have a few minutes for questions. Take it away. We have Dania.
Hi, yes, thank you. This is Dania Francis. Very interesting work, I agree. Thank you for sharing this with us. I wanna re-raise, I guess, the point that was made earlier about the possibility that you've got a lower bound on discrimination because of racial bias in measures like rearrest. And I guess I'm posing the idea that failure to appear may not be as race neutral as we might assume. In part because of things like, maybe it's more likely that Black defendants are experiencing either homelessness or transient with regard to their home address. And we know with evidence from, I think it was a 2018 University of Chicago Crime Lab study that showed that switching from some of these arcane summons systems to using text messages, right, like reduces the failure to appear rates. And so I don't know from that study whether there were greater reductions for Black defendants, for example, but it's worth checking out to see if that measure is not as race neutral as we might think. And in fact, maybe have similar racial structural undertones as rearrests do.
Yes, thank you for the comment. I definitely agree. And thank you for pointing out that paper. I'm certainly, open to the possibility that the failure to bears also have some sort of discriminatory component. So I would agree that overall that might, it certainly alleviates the problem from the police officer's standpoint, but maybe doesn't totally alleviate the overall problem. So another way to kind of interpret the findings could be to estimate them lower bounds. So certainly, correcting for misconduct does not erase discrimination. And so it might even be larger than we find.
Yeah, hi. No, very interesting work. I had a question about sort of the process by which judges kind of come to form their beliefs. So I was wondering if in your study, you sort of get at the idea that judges may place higher weight on the records of the defendants for the cases that they oversee, rather than what is happening with the population. And one thing that I noticed, for example, that would potentially be consistent with this is that you found that new judges do tend to be more lenient. So I was wondering the extent to which you might have newer judges who gain experience, and when a defendant commits a crime or something like that, they kind of update their beliefs, but potentially they overcorrect it in a racially biased way. So could you speak to that hypothesis with your data?
That's super interesting. I don't think we can necessarily get at what exactly the judges are believing. They are relatively, but it's an interesting point. I haven't thought about the overcorrection. I guess we could think about how to estimate some of the model parameters, such as signal quality and things like that, to see if they get worse or better over time. We just know overall, the longer you've been in, that kind of shifts down or shifts up your level of discrimination. But we can't say exactly why. And also the important point is that these are not the exact same judges. The new judge is one that came during our sample, and then the judges that didn't come in. So they're actually different judges. It would be nice to actually compare kind of across a time series of judges, which we could do, but we can't really explain whether it's because they're overcorrecting to certain crimes necessarily. Also, I think Peter's here now too. So Peter, if you want to jump in at any point, feel free as well. Or if you want to ask Peter a direct question.
Peter swatted us away. So
David's got it.
cool. I don't see any more questions.
And then, oh, I did have one sort of follow-up, and it's sort of related and maybe something similar to what I asked earlier, but I'd imagine you looked at the judge characteristics. So did you find evidence of like in-group biases? I'd imagine there are more white judges than black judges, but.
So they don't give us the information on any characteristics of the judges because they're a bit worried about that being too sensitive. So we don't actually know the race of any judges. And so all the characteristics that you saw are things that we can just compute based on kind of like, is the judge new? Is the judge lenient? But nothing about their background, which would be definitely interesting to look at. But unfortunately, they wouldn't allow that information.
Cool. So thanks a lot. Thank you, David. Thanks for a wonderful presentation.